Greetings, my name is Muhammad Zishan Hassan. This is my technical assessment for AI.SEE. Today I will be demonstrating running inference using YOLO PyTorch model, converting that model to ONNX format, running inference with the ONNX model, and as a bonus comparing both models using IOU matrices. I am using Cursor AI as my AI assistant coding tool, which helped me write and debug code effectively. So let's start by showing the project structure. Here you can see this is my project structure. The YOLO11n.pt, the YOLO version 11 nano model, the image, you can see our test image for which giraffe cars and the drivers etc. Docker configuration files, docker compose.yml and docker file for the environment, and the Python scripts you can see for each task. Basically I have divided my whole assignment into 3 tasks. First of all, I will explain each when I go through that. So first of all, I am explaining the environment setup. For the environment, I choose Docker, ensuring a clean and reproducible setup. Let me show you the Docker file. Here you can see the Python 3.11 Slim as the base image. I installed some system dependencies needed for OpenCV and then install all Python packages from requirement.txt. Here is the requirement.txt Ultralytics, the official YOLO library, Torch and Torch VN for the PyTorch, ONNX and ONNX Runtime for the ONNX Conversion and Inference, OpenCV for image processing, Matplotlib and others are visualization and charts for the optional tasks. Let me show you the Docker container as it is ready, environment is ready or not. So let me check that. Yeah, this is saying environment ready, so we can test our one by one task, that how our assignment is running and all. So for the task 1, our PyTorch inference, we will run our PyTorch model on this image that you have provided for the testing. For that we have to run our docker compose command. Basically this you can see PyTorch interference. This will load the YOLO model using Ultralytics library, run interference on the image, print out all the detected objects with their classes, confidence and bounding box, and saving the automated image with the detection drawn. So this is the basically code you can see here, and it will store all in the image with the output console here. So let us run the command. So it is like so this will print out an image with the detected boxed label. So let's PyTorch. Sorry for the command is a little bit modified here. Yup, this will create an image. You can see the output. There are 5 objects detected, 2 giraffes, object 1 and object 2 with the 95% accuracy, 94 to 95, 2 cars with the 89 and 85% accuracy, and object 5 is a person driving the car. Let's see in the image. You can see here the I think driver is here also. The output image is the PyTorch. You can see 2 giraffes with about 95% confidence score, 2 cars, the red one and this silver one behind it, and a person that is a driver visible through the windshield. Let me show you the output image and you can see here. So here you can see the bounding boxes drawn around each detected object with their labels, confidence score. The model did an excellent job detecting all the objects in the safari park scene like structure. So our second task is to convert enough PyTorch model to ONNX model. So for that we also have to run a command. So basically ONNX stand for Open Neural Network, has a universal format that allows model to run different platform and frameworks. The conversion is straightforward with the ultralytics. Just call the export method with the format equals ONNX. Let me run the command. So basically this is the file that convert our PyTorch model to ONNX model. You can see it is taking YOLO11n.pt, which is PyTorch model, and it will convert our ONN PyTorch model to ONNX model. So we have to run this file. The output is showing. It will take a little bit second, like 3 to 4 seconds. So yeah, you can see the conversion is completed successfully. The ONNX model is about 10 megabytes. The size is showing here, and you can see it is validated model and confirmed export was successful. So yeah, you can see in the file, this is the binary text file and the YOLO11x.ONNX model. So our third task is to train that image on this ONNX model and predict the differences between PyTorch model and ONNX model. So for the task 3, I run the inference using the ONNX model instead of PyTorch. The code is almost the same PyTorch version. You can see here the ONNX inference model. The code is almost same. I just loaded the ONNX file instead of PT file. The ultra latest library automatically uses the ONNX runtime for interference. And let us run the command for the ONNX model. So we have to run the file ONN. Yeah. So here you can see an output image some console log here, object 1, object 2, 2 giraffes, 2 cars, and fifth one is the person. And you can see in the image here, you can see the same box model as label like the PyTorch, but the little bit differences between the accuracy of the model. You can see here is the ONNX output image. You can see the detection look exactly the same as the PyTorch model, and for that, so there is a little bit difference. I think for the car in the PyTorch there is 0.92 and here is 0.91, or I think there is 0.90. So yeah, we can see here. So yeah, 0.90 and here is the 0.91. So there is a little bit differences between this. And for the optional task, I also have did a great job in that, and I have completed this whole assignment in 1 hour, so or less than an hour. So actually for the IOU comparison, there is a differences of chart. Let me run the command so that we can have a clear visibility of what is the difference between PyTorch and ONNX predictions and verifications. So IOU comparison, this will create two images. First of all, side by side comparison. You can see here, this is the prediction by PyTorch and this is the prediction by ONNX. Giraffe 0.95 both have the same, and the car has 0.95, 0.90, 0.91. Also there is a driver accuracy 0.33 in PyTorch and 0.34 in ONNX, and for the silver car everything is same. So for IOU comparison, for the optional challenge, our script, you can see here, this is our script, runs the both PyTorch and ONNX inference, matches corresponding detection by class, calculates the IOUs for each pair, creates the visualization charts. So I have run the both command, and you can see here also there is a graph comparison, sorry, chart comparison. You can see IOU scores and confidence comparison, both have identicals. I think here is the visualization chart. On the left you can see IOU scores for each object. All greens means they exceed the 0.95 excellent threshold. On the right is their confidence comparison. The blue bar are PyTorch and red bars are ONNX. They are virtually identical. And here is you can also have seen the side by side comparison I also have told you before, like here is this. So yeah, at the end, this is the whole assignment. I have first predicted the accuracy on the PyTorch model, then I have converted that PyTorch model to ONNX model, and then I have trained the ONNX model on the base image that you have provided for testing. So this is the end of an assignment. I have also completed the optional part, and you can I have also explained that. So as for assignment, as for AI assistant, I have used the cursor AI pro model and opus 4.1, which is the latest model, and I have helped in the setting up all the environment, writing some inner inference scripts, and while the matplotlib visualization. Along with this, I also have compatibility issue on the local environment and the Docker Compose file, so I have also resolved with the AI assistant. By the summarizing, I have successfully ran PyTorch interference, detected 5 objects. Task 2 was converting the model to ONNX format. Task 3 was run ONNX inference with the identical results. And with the optional task, I am happy to discuss any question about the implementation, and if anything is required from me, please feel free to ask. I am always there to help you. Thanks, bye.